Hello everyone. If you're watching this video, you may be having trouble with problem 6.42 on mastering chemistry, or if you're working problems in the book, you may be having come across this problem and wondering why you're not getting the correct answer. Okay, and so here, really the key is, we'll go through and read the problem first. So a sample containing 4.80 grams of oxygen has a volume of 15 liters at constant pressure and temperature. If oxygen is released until the volume is 10, so the volume is going down, how many moles of oxygen are removed? Okay, so here we're comparing the grams, which we know we can convert to moles, okay, but we're comparing grams and volume. So we can convert grams to moles, so really we're comparing moles and volume. Okay, and the law that relates these two is Avogadro's law, that volume and the number of moles are directly related if temperature and pressure are constant. So this means if the number of moles increases, then the volume increases, which makes perfect sense. Okay, and so the problem here is asking us to use Avogadro's law. Okay, so if we look at the formula for Avogadro's formula here, okay, it's V1 over N1 equals V2 over N2. And if we rearrange this problem, I like to look at these linear. I think it just helps with the algebra and prevents mistakes. Okay, and then we can rearrange to look what we're trying to find. We're trying to find N2, because we're trying to find how many moles would be removed. Okay, and the other key word here is removed. Okay, this is probably the part that you might have messed up on, would be at the very end. Okay, so if we're looking for N2, we can rearrange and we can solve for and say that V2 N1 over V1. Okay. The first thing we have to do is we have to convert from grams to moles, because N is equal to the number of moles, not of grams. So we have to take our grams of oxygen and we are going to, if you look on the periodic table, the atomic weight of oxygen is 16, and you have two of them. So you would have 32 as your molecular weight there, your molar mass, and that's always out of 1 mole. And so our grams cancel, and we're left with 0.15 moles O2. Okay, so this is our N1. And we have our volume, so 15, this is our V1. And then the 10 liters is after the oxygen's released, so this is our V2. Okay. So we want to be sure we don't mix up our V2 and V1. So our V2 is 10 liters. Our N1 is 0.15 moles. And our V1 is 15 liters. We're left with 0.10 moles. And so this is how many moles we have after the oxygen is released. It's asking you for how many moles are removed. Okay, and so what we have to do is we go back to how many moles we started with. So we started with 0.15. We ended with 0.10, and so 0.05 moles of O2 are removed. I think the most common mistake is just to stop here. You're finding N2, and I don't know that your book really goes much further than that, but the key here is asking you for how many were removed. So you started with 0.15 moles, and you've ended with 0.10 moles after the oxygen's been released, and so you're removed, 0.05 moles were removed when the oxygen was released. Okay, we have a sample of gas, the same sample containing the 4.80 grams of oxygen. So on the previous slide we found that when we converted grams to moles, we got 0.15 moles of oxygen. Okay, we have 15 liters again as our V1. Okay, and we're looking for the volume this time. So we're trying to find V2. Okay, and once again we have grams. So we're going to have to convert grams of helium to moles. Okay. So if we look on the periodic table, we see that we have 4.003 as our atomic weight of helium, and so we end up with 0.999 moles of helium. So basically almost 1 mole of helium. Okay, and we're still using Avogadro's law, so if we rearrange, now we're looking for V2. So if we isolate V2 by itself, that should be a 1 there. Looks like an I. There we go. Okay. Alright, so now we plug in, so our V1 is 15. Okay. And now we have to, this is the most common mistake, is finding N2. So we're going to come back to that. Okay, our N1 is, again, 0.15 moles. Okay, and so N2 is how many moles that you have, total moles you have at the end of the experiment, or after the grams have been added, so after the 4 grams have been added. Okay, and so you have to add up both moles to see what your total number of moles is. And so here we have 0.15 moles that we started with, and then we added 0.999 moles. Okay, so we can plug that in, or you can add those up and then plug them in however however you would like. So you end up with about, we do the math here, so we end up with V2 being about 115 liters. So our, here if you want to go ahead and add that up, you end up with about 1.15 or 149 moles. Okay, so when you do the math, you end up with about 115 liters. So you started with 15 liters, and then when 4 grams of helium are added, you end up with about 115 liters. So the volume goes up quite a bit. This concludes the problem 6.42. I hope